exponential functions. These are functions that look, let's see if we had a x and y axis there. These are functions that would start off really small and then increase really fast, or quite possibly the opposite. They might start off really big and then get smaller as you head off towards positive infinity. So both of these are called exponential functions. They are functions of the form where f of x equals b to the power of x, where b is just some number. If you want the green one, if b is greater than 1, it's an increasing function. So this is the one that's in green to the left. I don't know, that'd be like 3 to the power of x or something. But it can also get smaller if b is between 0 and 1, then it's decreasing. So an example is something between b and 1. This one over here would be like the function of 1/2 to the power of x. Something like that. The trick is to be able to identify these from a table. So what you're going to be given is you'll end up with some table, x's and y's, and you'll have like 0, 1, 2, 3, and then on the side you'll have 1, 2, 4, 8, let's do one more, 16. And if you try to do this the regular way by looking at how much each one changes, it's not consistent. I mean, it kind of follows a pattern, but it's not the same number every time. So this right here, this can happen, but it just means that it's not linear. It doesn't have a consistent slope. There's a y-intercept, but it just means that it's not linear. Instead of looking at the adding or subtracting part, like what's happening to the y, we're going to use a different operation. This goes to the whole thing. Sometimes these are called geometric. And what that implies is we're not going to look at how much you're adding or subtracting between these two, but we're going to look at how you would turn a 1 into a 2. Or I'm going to take a ratio here. If I take the 2 and divide it by the 1 in front of it, I get 2. Then if I do the same for the next one, if I take the 4 and divide it by the 1 in front of it, I get 2. And then 4 turns into an 8, and if I take 8 and divide it by the 4, it changed by 2. And then if I go 8 to 16, 16 divided by the 8 is also 2. You see how everything here is the same number, 2, 2, 2, 2. It's like you just multiplied by 2 every single time in the y column. Well, this is what a exponential function looks like. And that change there, I don't know what you want to call it, constant of change, that is the b. So our function for this particular one here would be 2 to the power of x. That ratio that we found that was the same every time, that was the b. And if we think about this, it makes sense, right? If I take 0, 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4, 2 times 2 times 2 times 2 makes 16. So this would be an exponential function. This one would look like the green one up here. Start off really low and then get high really fast. Now, if you need to, you can pause it, but I'm going to turn off this layer. Now I'll do one more, just so we can see. So I got X, I got Y, there's a phone. And let's say this one I got 0, 3, 9, 27, and 81. Now that I've already told you this, you can probably figure out what it is, but let's pretend you don't know. So basically, we're just trying to figure out what B is. We're trying to figure out how much each one of these changes. So if I go and I look at how much, if I look at adding, right, I'm getting a different number each time. It's not happy. I don't like it. 54. So we're not gonna use those. Instead, we're gonna look and see how much it changes between each one. Instead of looking at those things, let's look at the ratio between the two. So between 0 and 3. Oh, woo! It's not a 0, it's a 1. Between 1 and 3. Take 3 divided by 1, I get 3. From 3 to 9. 9 divided by 3 is 3. From 27. 27 divided by 9 is still 3. And then 81 divided by 27, you guessed it, is 3. All right, so this constant ratio of change, this is what the B is. So our function for this is 3 to the power of x. It's not going up by the same amount, but the ratio is the same, how much it changes from one to the other. Or you can think of it as, if you take this one times 3, you get the next one, times 3, you get this one. That constant multiplying tells you what that B is. So it's 3 to the power of x. That's it.